So this is going to be the second part of the day one notes. The flipped homework last night started day one, and there are parts that I said we would talk about at the start of class today. So that's what this is going to be. So for example, I started to help you fill out your chart. The chart is on page 18. So we started filling out the chart, and now we're going to finish and see what you put in for your boxes. So let me switch colors so we see our new entries. 4 to the 4th, 256. Those of us joining me on the chart right now, fill in what we fill in together, and then when you make up your day one flip notes homework, you can go back and fill in what's already in blue. So join me with what I'm writing in purple. 5 squared, 25. 5 to the 3rd, 125, and 5 to the 4th, 625. Remember, you are only accountable for what's not in gray.
Wait, Miss, can I?
What is 7 squared? 49. 7 to the 3rd, 343. 8 squared, 64. 8 to the 3rd, 512. 9 squared, 9 to the 3rd. Good job. 10 squared, 100. 10 to the 3rd, 1,000. 10 to the 3rd, 10,000. And the rest of this list, I'm hoping we recognize from, or remember from Algebra 1. 11 squared, 121. 12 squared. Go down, keep going. 225. Again, what's in blue was part of the flip notes. And we just finished checking the rest of our tables together. Everything in gray you're not accountable for. But what is not in gray, we will become familiar with by means of practice. So in the notes, I said we would start class by going over numbers 9 through 12. So can someone share with me what they had for number 9? What is the third root of 125? Equals 5. Because why? Good. 5 times 5 times 5. How do you use that? How do you say that using an exponent? 5 to the 3rd equals 125. How would I read this one out loud? How do I read number 10 out loud? Let's do it together. The 4th root of 16. So you all put it together and tell me. I only heard one person. How do I read this out loud? Everybody. Good. 4th root of 16 is 2. Because why? Exactly. I just heard multiple correct ways of saying it. 2 times itself 4 times is 16, or 2 to the 4th is 16. 3rd root of negative 27.
Negative 3.
Yes. In the video last night, we talked about how I can take the odd root of a negative, because what is negative 3 times negative 3? 9. But this is to what? How many? We got one more. Yes. So negative 3 to the 3rd does equal negative 27. But can I take the 4th root of negative 625?
Nope.
No. No solution. And let's really make sure we can see why. What might I say by accident is the answer. So let me go to my chart. So I'm going to, well, but let's say I just didn't know. I didn't know. So if I'm taking the 4th root, which column do I look at in my chart? The 4th one, and what number am I looking for? 625, and I look left, 5. So 5 to the 4th is 625. So instead of no solution, maybe I say negative 5. So that would mean how many negative 5s multiplied together? 4 of them. So let's see. 1, 2, 3, 4. What is negative 5 times negative 5? A positive 25. Yes. Yes, good. And then negative 5 times negative 5 is 25. That's a positive times a positive. Will you ever get a negative from that? It's never going to happen. So that's why it's no solution. So we can take the odd, in number 11, this does exist. You can take the odd root of a negative. You can never take the even root of a negative. So there was 9 through 12. And then we had some over here on the right side we said we would talk about. For those of us who were joining this for the first time right now, I can catch you up very quickly. Listen to what I'm about to say. When I have a fraction as an exponent, the denominator is the root. So right now, what fraction is in number 16? Number 16 right here, what's the denominator? 3 is the root, but how would I say that out loud? Do you say 3 root? What do we say? Third root, not to the, third root of 729. Everybody, third root of 729. And that's what I write. Third root of 729. Go use your chart, please, and find me the third root of 729. I'm going to write that a little neater. I saw a couple people look at their chart. I'm going to wait till I see more people actually go to their chart, go to the x to the third column. As a class, what are we saying it is? 9. So how do I read this one out loud? How do I read number 19 out loud? Second root? Do we say second root? No. Square root of 64. Square root of 64 equals 8. From last night, what do you know about this symbol? Yes, there's an invisible little 2. Think back to 9th grade. Whenever you saw this symbol, what did you call it? Square root. What number is associated with the word square? 2. So there's technically an invisible 2 right there. We just never write it. Number 20. I need a new voice. How would I say this out loud? Number 20. Say it again. Yes. Very good. Fourth root of 1 equals, what's the fourth root of 1? 1. Because literally 1, 4 ones. 1 times 1 times 1 times 1, 1. Now, 22 and 23, I highlighted to you last night that we do not have parentheses grouping the negatives inside, right? So it's really like negative 1 times 16 to the 4th. Yes, a negative times a positive. So both of these do exist. So I'm going to focus on 16 to the 1/4, which I can rewrite as how? What is 16 to the 1/4? Say it again. 4 to the 6? No. Let me ask you this way. Can you tell me how I would write that using a radical sign? What do we? Yes. 4th root of 16. Notice, see how the negative is still outside? So what is the 4th root of 16? 2. So what's my answer? Negative 2.
Oh, so like you bring the negative inside.
The negative is outside, correct.
So we wouldn't get a negative.
Correct. Well, we do end up with a negative 2 as an answer. But it's because this is really negative 1 multiplied by the 4th root of 16. there is not a negative grouping this underneath the radical. So, yep, I'm listening. If there were parentheses here, would 22 exist? If I had parentheses, would 22 exist? No, because it would be the fourth root of a negative 16.
Okay, so if it's inside, then it's no solution. If it's outside, then
Yes.
Like negative 2.
Yes, exactly. If I had parentheses, then that means that the negative would be with the 16 underneath the radical. Can we take an even root of a negative? No. 23 would exist regardless, parentheses or no parentheses, because I can take the odd root. How do I read this out loud, number 23? I heard it. Cube root or third root. Oh, is the negative with it? Of 27. Negative 3. Last one, 24. New voice. Somebody take it. Who's got 24? How do I read it out loud? Someone from this side. How do I read that out loud? Go ahead. Perfect. Third root of 343. 7. So knowing the correct language is literally half of getting it right. If we know how to say it, we'll know how to write it. If we know how to write it, we'll know how to do it. In last night's video, does anybody remember what I said was in common about 13 to 24? Look at the fractions. What do you see is the same? They all have 1 where? In the numerator. 1/2, 1/3, 1/5, 1/3, 1/4, all the way, right? Because the focus of last night's notes was to help us get comfortable with the root. Where's the root always located in that fraction? In the denominator. But that's not always going to be the case that the numerator is 1, which is exactly what we're going to talk about when we finish this section of notes right here. Is there a question? Yes.
So you can like have more than 5, right? You can have more than 5 roots.
Good question. He's saying that the table ends at x to the 5th. Could we technically have a column for x to the 6th and x to the 7th? Can I take the 8th root of something? Yes. We are just focusing on that small section. Great job. Great question. So let's fill in these notes. What do you see as a new piece? Notice here, instead of 1 in the numerator, what do we have? M. We know part of this already. What does n represent? The root. N is the root. M is the power. So that's the start of class's new learning, which we're about to go over right now together. All last night, it was always to what power? The first power, because 1 was in the numerator. We're going to learn how to have something other than 1 as a power. It's not bad. So I read this as, right here, what root is this? The nth root of, so let's write that first, nth root of a to what power? Not anymore. M. A to the m. Now we have 2 ways of actually writing this. Do you notice how numbers 2 and 3 are the same? Because this power, this m, could either be under the radical or outside. So we could write this as nth root of a to the m. If you would like me to show you the math behind why that works, it's all about exponent properties. So I definitely can do that. Let me know after class and I'll show you how that works. So let's write a little note. Power m can be written under the radical or outside the parentheses. And I'm going to highlight that to make that stand out. That's important. Notice, do we say it the same? How would I say this out loud, the second one? Can someone read that out loud? Nth root of a to the m. Nth root of a to the m. How would I read this out loud? Number 3. Nth root of a to the m. So even the language literally is exactly the same. We'll practice writing both of these right now. So we have 4 to practice. It says rewrite the expression in rational exponent notation. Rational exponent just means fraction exponent. So when you hear rational exponent, what word should immediately come to mind? Fraction. Fraction as a power. From last night, what is this called? In general. Yes, it is the square root, but in general, it starts with, there's a word that starts with an R. Radical. So radical notation, which will come up here, that's the difference. In 25 through 28, what notation am I starting with? What was this called again? Radical. So here we are starting with radical notation and going to rational exponents. Good. So let's try this first with number 25. How do I read this out loud? Number 25. Cube root or third root of 125. So it's 125 raised to what power? The 1/3. Where's the 1 in this original expression? Where's the 1?
Right beside the 125.
Right here.
Yeah.
Do we ever write that little 1?
No, because it's always
Right. What is 125 to the first power? It's 125. But it is there. That's where the 1 came from. 26, we change it up a little bit.
Change that to the third.
So let's take the base. What's the base? X. So start there. X. So I hear some confident answers, and those of you that just said that, you are correct. But for those of us who are like, not sure, how would I read it out loud? Read 26 out loud.
What's 5?
Fifth.
The third. So cute.
That was a great mix of answers. Let's all say it the right way together. I'm going to say it, and then you say it. Fifth root of x to the third. You guys. Notice how you said fifth root? Where does the root go in the fraction? In the denominator. What's the power? X to the 3/5. The numerator is always the
Number, like when you're
the numerator is always the power. The denominator is always the root. Let's do it again. Denominator is root, numerator, power. Numerator, power, denominator, root, always. Question? Good question. She's saying here, I wrote the 1/3 with kind of like a diagonal division symbol, and here I used one that's more horizontal. Both are acceptable. It's the same. Whatever you prefer. 27. How do I say 27 out loud? Yes. So I've got 8x squared, y to the 6th, raised to the 1/3. That's as far as we're going to take it today. But using our properties of exponents, What technically could you do with this 1/3? We can send it in, right? However product, you distribute it in. That's where we're headed. Right? So yeah, oh yes. So last year you learned how to send in whole numbers like 2, 3, 4. The next level of learning, which brings us into 10th grade algebra 2, is we're sending in fractions. And we have the skills to do it. Yes, you do. I promise you do. But for today, are we doing that today? No, today is just practicing moving between the notations and evaluating when we can. So that being said, number 28. 28 is a little interesting. So take a second to look at 28. Is it? Is it the same thing? 3 is on the outside. Well, let's start on the inside.
Wait, so isn't that the power?
You're on the right track. What invisible little number is right there? A 2, because I would say, what would I call this? Square root. So let's just start there. 100 m n to the 4th raised to what power? To the second power? For right now, ignore this 3 on the outside. To the 1/2. Because we're about to do it right now. Right now, I just focused on writing the inside. But is this complete? No. It's all raised to what? Power of a power. What do I do with the powers? Multiply them. What is 3 times 1/2? Stick with what you said first. So 100 m n to the 4th. That's a little messy. Raised to what power? When you say 3 over 2, what does that mean? 3 divided by 2? So what I did first was just the inside piece. I just looked at the inside. This is the square root of 100 m n to the 4th, yes? Well, square root is associated with what rational exponent? It's the same as raising something to the 1/2. 1/2 is not the second. Raising something to the second power. Oops. When you say second, what does that mean?
I mean the denominator. That's what
But we can't just say half a fraction, though, right? So be careful with the language. If you say second power, what does that mean? Squared. X squared is just x squared. X to the 1/2 means square root of x.
Wait, why do you have the 4?
So why do I not send this in? I chose to just focus on the radical and the power. She's saying, why did I not send in 1/2 to the inside? And that's a valid question. That's a level of evaluating we're going to work towards. The only goal of this question was to not have a radical in my notation. So to make that happen, I went from a square root to the power of 1/2, all of it, whatever was on the inside. And then it's still raised to the power of 3, power root. So here, check it out. What I just said, so I can point to it if you're watching the video. Here's my power, here's the root. 3/2. Watch what would happen if I read this out loud. So let's start here. How would I read this out loud? What's my root? So the square root of the inside raised to the 3rd power, because the numerator is the power. We're going to practice in a minute. That's what's coming up right after this. We've got 4 more for the notes, and then we're going to practice. So 29. Now what am I starting with? What kind of notation? Rational exponent notation, and I'm trying to get to radicals. Remind me, what's the denominator again? The root. Numerator is the power. Look at the denominator first. What root is this? Square root of 64, technically raised to what power? Are we going to write the 1? No. I mean, we could. What is that equal to? Because, see, it says evaluate when possible. What is the square root of 64? 8. And we're done. That's it? Yeah? Yes, I'm serial. Okay, number 30. Ideas. Where do I start looking first? Not 5 square root x. You're on the right track with 5. 5th root. 5th root. 5th root of x squared. But here I wrote it underneath. What's my other option? Where else could I have put the power? So let's do that right now. Or 5th root of x squared. Those are the same. So there's our first example of where the power could be underneath the radical or outside the parentheses. $31. Who wants to take a shot at 31?
You said me.
New voice.
Shamar wanted to do it.
You got this. She's going to take it. What's in the denominator? What's in the denominator? Yep. 5. So what root am I taking? 5th root, exactly. 5th root of technically, this is to the first. Raising something to the first power. So I'm going to leave it there for the sake of the notes, because it technically is there. But raising something to the first power, does that change anything? No. So we're done right there. Last one, 32. Who's got it? Yes. 4th root. She started it. Can someone else finish it? To the 3rd. Good. Note this? Okay. So 4th root of 5xy to the 7th raised to the 3rd. Notice, what did I put around the base? Parentheses, because all of that is part of the base. Here, I wrote the power where? This is outside? This is under the radical. So how else could I have written this? Put the whole radical underneath. Inside parentheses. 5xy to the 7th. Close parentheses to the 3rd. Both are accurate. Both are correct. So again, the power can either be under the radical or outside the parentheses. So this finishes the day 1 notes completely. Today's classwork assignment is page 21, which is the practice. So those of you who did not, for whatever reason, didn't have a chance to watch the day 1 notes, if this quick 10 to 15 minutes finish was enough for you to feel confident to try this, that's great. I still ask that you go back and get those notes, because that's where that understanding comes from. For those of you who would like to take the notes right now, I'd ask that you come sit in this front section, and I'm going to put the video up for you to take the notes now that you missed last night. Tonight's homework is 8.2 Day 2 Flip Notes, page 22. So at the top of page 22, please put tonight's flipped homework at the top so you remember. You can also put it on the front of your workbook. Page 22 is tonight's flip notes. It's not too long, right? It's just one side of one page, so it's not bad. I have those for you. Day 7 of the unit, second day of 8.2. Right? So page 22 is the flipped homework note. That's my last little announcement for class. So again, those of you who are wanting to catch up on the notes right now, where are you going to come sit? Up here, because the speakers are only so loud. Everyone else who's working on the practice, where are you going to sit? In the section in the back. And if you choose to not catch up on the notes now that you missed, when are you supposed to do it? Right. So if you didn't do last night's, how many videos do you need to watch over the weekend? 2. Remember, if we start slipping a little bit with our videos, is that a good experience? No. So today we'll make some adjustments for this next day with our practice. All right. So let me pull up the Google Classroom video. And today's class notes will be on Google Classroom as well as day 2. So A, moving between notations. This is ultimately our goal. Oh, I'm sorry. Let me move that to the beginning. Okay, we ready?
Yes.
Hi, everyone. These are going to be notes for 8.2 day 1. We are starting a brand new section today as part of our Unit 8. And this section is all about radical and rational exponent notation. Those are both words that we'll know the meaning of by the time we're done with today's notes. But to start today's notes, we're actually going to work on filling out this table together. Those of you working on the practice, check in with me if you have questions. That we and then you can actually finish filling out the table on your own, and we will be using this table often as part of this section. Yes. And how does 4 divided by 2 simplify? If you look at the start of it, so you can take that one off. Number that will be responsible for it. Fill in the non-shaded boxes. Yes. So if I start what is the 4 here, what is this? 1 squared. 1 squared. Go to my chart.
Yeah, I went to the chart. I didn't have it.
1 to the 3rd means 1 times 1 times 1, that's still 1.
Let's see, 8.1.
1 to the 4th is 1, and 1 to the 5th is 1.
I went to the 4th. Oh.
2 to the 2nd power
so the answer
is 4.
Because think about it, right?
2 to the
4,
3rd power is
3 times 3 is 9, times 3 is 27, times 3 is 81.
2 to the 4th, so if we need help to see that, that's 2 times 2 times 2 times 2.
I don't know if that's right.
2 times 2 is 4, times 2 is 8, times 2 is 16.
Nope.
Multiply that by
here's my power.
1 more 2, and I get
what's
32.
the root?
So in other words,
so
2
if I'm
to the
doing
5th
power divided by root,
equals 32.
I have the whole argument raised to the 4
squared is
divided
9.
by 2.
3 to the 3rd is 27. Because 3 times 3 is 9.
Or no, the power goes 4.
Power's on top.
All right, from here, you may need your calculator.
Hold on one sec. I realized the video.
If you want to go grab it, now would be a good time.
Hold on. This is still recording from class. I'm just going to stop this recording, and then I'll be back around to help everybody work on the classwork. So just let me stop this real quick. People listening to the video, have a great day. See you in class tomorrow.